All right, this is 3-4, completing the square. So our objective today is that you can learn to solve and graph a quadratic function by completing the square. Completing the square is a method we use to take quadratics from standard form to vertex form. Vertex form. So we're going this direction today from standard to vertex. This method is super useful. Vertex form, we really like vertex form, especially for graphing quadratics. So if we're able to take something from standard to vertex, it gives us a lot of maneuverability there. There is also a way, you can also get the x-intercepts from the vertex form easier than you can from standard form. So it gives us sort of easy access to both of those things. So bear with me on this one. Completing the square is often something that takes a little bit to catch on to. So the first thing that we're going to do is just sort of familiarize ourselves with perfect squares. Perfect square trinomials are trinomials or quadratics that can be factored into two identical, that's what goes here, identical binomial factors, meaning two of the same factors. In other words, you can write it as something squared because it's two of the same binomials. So what we have here is a bunch of examples of perfect square trinomials. So I sort of encourage you to just pause me here and look at these binomials and see if you can notice any patterns, and see if you can figure out what these are on your own, what patterns you're seeing in these examples. So they're showing, to clarify, they're showing in standard and in factored form. So both of those are equivalent. They're just written in a different way, in a different form. I've already pre-highlighted all of these numbers as well, and so that you can easily see the patterns, hopefully. So go ahead and highlight your own and see if you can figure out the patterns here. So the patterns between these numbers become pretty clear when you look at more than one of them. To get from the orange to the blue number, which is the first question we have here, to get from the orange to the blue, we're always dividing by 2. Notice that 3 is half of 6, 4 is half of 8, -9 is half of -18. So to get from orange to blue, we divide by 2. That works for every one of these examples. Then to get from the blue to the pink, notice that we can square the blue number and get the pink number in any of these examples. 6 squared is 36, 8 squared is 64, -3 times -3, so squared, equals +9, and -2 times itself is +4. So this is squaring whatever number we have for blue, gives us the pink number. So if we were just to have, for example, if we were to have nothing except for just this part of the trinomial, we would be able to fill in all the rest of it, because from orange to blue, we divide by 2, and then to get from there to this number, we square it. And so we can sort of combine both of those steps. Going all over the place. We can combine those two steps to be divide by 2 and square it. So to get from the orange to the pink number, we have to divide it by 2 and then square it. So if we write that in a mathematical equation form, we can divide by 2 like that and square it. And I'm just going to leave this as an orange dot to just remind you that that is the number we're plugging in, is the orange number. We divide it by 2 and then we square whatever we get. So this next page has a couple of examples of, not examples I guess, but practice, filling in the blanks for perfect square trinomials. So what they give us here is just the orange number, and they're asking us to find the blue number, and the pink number, using our patterns that we noticed on the other page. So remember, to get from the orange to the blue, we divided by 2. So 18 divided by 2 is 9. And then to get from this one to that one, we can square it, which is 81 in this case. 9 times 9 is 81. 14 divided by 2 is 7. 7 squared is 49. Negative 22 divided by 2 is negative 11. Negative 11 times itself is 121. You can double check that on a calculator. 121. Good, so we've sort of familiarized ourselves with what these things look like, and we can even create them. If we only just have like the 2 first terms of it, we can create the whole trinomial in both standard and factored form. So let's move into completing the square. So completing the square involves perfect square trinomials. We are completing the square in the sense that we start with part of a perfect square trinomial and we complete it in order to write these in vertex form. I would just remind you that vertex form looks like, and I'll write this down here, vertex form looks like y equals, it had an a out here and an x minus h squared in parentheses and then a plus k. So the perfect square trinomial gives us this x minus h squared. Because perfect square trinomials are 2 of the same binomials multiplied together, they can be written as x minus something squared or x plus something squared. So it's that part that's the hardest to get out of our standard form. Perfect square. I'll just write a little square there. So again, the steps are on the left, so hopefully you can follow those if you get confused later. Again, move everything to one side so that it's equal to 0, so we have like an a, b, and a c term. And our job here is to separate the first 2 terms from the constant with parentheses and to make room for yourself to complete the square. So what we're going to do is make a perfect square out of these first 2 terms. So we're going to, in order to give ourselves room for that, we're just going to move this over, and I put them in parentheses. I'm going to move it over, leave a little space so I can complete the square, and then I'll just leave plus 5 over here. So I'm just leaving myself a lot of room. Yeah. I just noticed that the notes, the notes that are attached below have a different example. That example is also good. Just know that it's different than this one. So anyway, I separated the first 2 terms, and our job next is to complete this square. This is our perfect square trinomial. We know eventually we're going to write it as something squared down there. So here you hopefully can see that this little piece of it is pretty much the same as something like this, where we're filling in the pink and the blue number. So we have the orange here, and the pink and the blue is down here in factored form. So 8 divided by 2 will give us positive 4, which goes here, and 4 squared will give us 16, which goes there, positive 16. So we have just completed the square. That's awesome. Here's the issue, though. We're going to ignore this part down here for a second. But in this equation here, we just added 16 on one side, and we are that's not allowed. We can't just add 16 to one side of the equation and say it's fine, because we've just unbalanced our equation and we've made it completely different. So in order to keep the balance, we also have to take away 16 so that we don't end up unbalancing our equation. So we have to keep, whoa, that's a highlighter. I'm all over the place today. We have to keep the balance of our equation if we added 16, we also need to take it away. So whatever you add, you take away. And if you're not going to ever subtract something, but just keep the balance so that you don't, your sum total of damage is 0, right? We haven't actually changed anything in this equation. We just added 16 and took it away again. And so we didn't really change it, which is what we wanted. Now this perfect square trinomial we've already written in factored form. These things are the same. we just need to put this down here as well, and I'm writing this in a laser pointer here because this is just a number. 5 minus 16 is just a number, so I'm going to just replace all of that with 5 minus 16 is negative 11. So this turned into negative 11, and this turned into x plus 4 squared. And believe it or not, that's actually it. We have our quadratic in vertex form here. There's no a value, but this is vertex form. We've gotten there. So I'm just going to write that here, that we've got it to vertex form. And then I'm going to write a little line because getting it to vertex form is really the hardest part, and probably the most useful thing that you can do with completing the square. There's also, and there continues down on the steps here, we continue to have like, it explains how to then find the x values of, like, find the solutions, right? So this whole unit is about finding solutions of quadratics. So, so I'm just going to keep going and show you how you might find the solution to this quadratic. We just need to get x by itself in this equation. So we add 11 on both sides, and we end up with x plus 4, parentheses squared, equals 11. I'm going to move that down. We'll see why in a second. So now I have a squared on one side. I'm going to have to square root both sides in order to get inside of those parentheses because that's squared. The problem with that, though, I guess it's not a problem, but whenever we square root both sides of an equation, we have to account for the positive and the negative version of what we just did. You might remember that from 3.1 where we were taking the square root. So I need that plus or minus. I don't know what the square root of 11 is. I bet you don't either unless you were to type it into a calculator. And I want to leave it like that. You can get decimals, but MathSpace is going to be happier with we call this radical form or exact form. So I'm just going to leave it in as the square root of 11. On this side, I still have x plus 4. I square rooted both sides, so that's gone, but I still have x plus 4. So I'm going to need to take away 4 from both sides. And finally, we have positive or negative square root of 11 minus 4. So that's actually two answers. There's positive square root of 11 minus 4, and there's negative square root of 11 minus 4. So that gives us those two answers that we expect when we find solutions of quadratics. So that's it. So we've put it in vertex form. That's probably the most important part. And then we solved to get the solutions to our quadratic. So I'm going to keep going and do some examples here. Because really, like almost every math topic, it gets a lot easier the more times you do it. So we're going to do that. So remember, our first step is to give ourselves all kinds of room. So I'm making a perfect square out of the first two terms, lots of space, and so here's my orange number. I need my blue and my pink because we're eventually going to write this in factored form. There we go. So negative 10 divided by 2. Be careful about this one because it's negative. It's a minus 5 in here. That's our divide by 2. Divide by, ooh, it's too small for my pen. Divide by 2. And then we square it. I'm just going to write a little square. We square it to get the other one. Negative 5 times negative 5 is still positive 25. Be careful about those signs. And because we added 25 on this side of the equation, we also have to take away 25, keeping the balance. That's the thing everyone forgets. Keep the balance. Keep the balance. So we added 25 and we took it away again so that it's balanced. And then we can combine those two, because that's just positive 3 minus 25, so that's minus 22 on the outside there. And that's in factored form. I mean, vertex. I always say factored form because I was teaching factoring today. Sorry. X minus 5 squared minus 22. There goes the bell. Okay. So let's keep going. Let's do this next one. Give myself some room. This one, on these ones, we're just getting it in vertex form. We're not going all the way to a solution because we're trying to get good at just this part. So we have our pink number, we need our blue and our orange. This is in factored form. There we go. Okay, so 6, it's got an X in it because it's in factored form. Negative 6 divided by 2 is negative 3. And negative 3 times negative 3 is positive 9, squaring it to get that number. Wait, did I highlight this wrong? Oh, I did. I'm the worst. This should be... Let me erase that. Okay. This should be our pink number, and this should be our orange number. Did I? Okay, now I'm second guessing myself. Wait, the middle number is orange, the last number is pink. Okay, I just highlighted it wrong again then. The middle number is orange, the last number is pink. There we go. So, to keep the balance, we also have to take away 9, because we added 9, but we got to take it away as well. So this is me, I'll just write balance. Hopefully that tracks balance. There we go. Good. So then outside we have positive 8 minus 9, which is minus 1. There's that. And this is in vertex form. Y equals, I'm just writing it again because it's kind of messy up there. There's our vertex form. Let's see, we need to do an example where there's a number in front of the x, because that can get tricky. I'll let you do number 3 if you need to. There, of course, there's the notes below as well if you need that example. So I'm going to do one where there's a leading coefficient, because that's where it gets a little tricky when we have a leading coefficient. That's why I changed the example from before. I used to have one where it had a leading coefficient. It was too confusing to start with that example, so we just learn it later. So our leading coefficient here is 2. Whenever there's a leading coefficient, we cannot complete the square with a leading coefficient. Like this guy, this is a problem. We can't do that. So we have to, before we do anything else, we can put those first two terms in parentheses, but before we complete the square, we have to factor out this leading coefficient out front. And we have to factor out of the whole parentheses, because that's the only way, that's how math works, right? You can't just factor it out of one term, it's the whole parentheses. So I'm going to factor out a 2 out front of these parentheses, which leaves x squared in here and 8x in the middle. It doesn't change, this number doesn't change out there because that's not part of the parentheses. And now we don't have a leading coefficient here, so we can complete the square. So the middle number is orange. I've totally confused myself there. The middle number is orange, and we're gonna complete the square now. 8 divided by 2 is 4, and 4 squared is 16, positive 16. And here's where it gets kind of crazy, guys. The keeping the balance part of this, we added 16, right? But we added 16 inside parentheses with 2 multiplied by it. Like this 2 is multiplied by everything. This 2 is multiplied by everything inside here. Mathematically, that's just how it's working, right? So when we added 16 here, we didn't actually add just 16. We added 2 times 16. So in order to keep the balance, we have to take away 2 times 16. So let me just maybe, I will maybe do colors here so you can see. I'm keeping the balance by taking away 16, but I have to take away 2 times 16 because the 16 is in parentheses that is multiplied by 2. So it just gets a little bit funky there at the end where we're keeping the balance. Okay, so we have -8, we have -8 minus 2 times 16, which is 32. So I'm just gonna put a little middle step here so that I can keep track of what I'm doing. This 2 also stays in front of the whole equation. Like, it doesn't just disappear, it still has to be there. It actually becomes our a value in our vertex form. So this is minus 40 on the outside. That's -8 minus 32. So the 2 stays out front, and this is that becomes our a value of our vertex form. So here's the vertex form. It got just a little bit crazy when we were doing the balancing act here. Got to be careful when there's like a leading coefficient, because you have to factor that in when you're balancing your equation. Okay, I will do probably both of these next ones just because it's good to see a lot of examples, especially of the ones where you have to factor out the leading coefficient. So we have 7x squared plus 14x minus 8. I'm going to have to factor out a 7 out front. So I have 7 out front, and then an x squared and a 2x. Don't forget to take the 7 out of the middle term as well. And then we can complete the square because there's no leading coefficient. So we have our orange number. We divide by 2 and get 1, positive 1, to get our blue number. Nope, that was orange. To get our blue number, and to get our pink, we square 1. 1 squared is just 1. So there's that. I'm going to just color this 7 blue so we can tell. When we keep the balance, we have to take away 7 times the 1 that we just added, which ends up being 7 anyway. But then we have -8 minus 7, which is -15. Yeah, -15. And the 7 stays out front of our equation. And that's vertex form. Okay, one last one. This one has a negative leading coefficient, which just makes it, we just have to be careful when we're factoring it out to make sure that we're factoring out a negative. That's not 14, it's 4. Also it's plus, here we go, minus 21 on the outside of our parentheses. We have to factor out a -2 out front. So we end up with y equals -2 x squared plus 4x. Nope, I just did what I said not to do. So we're factoring out a -2 out of everything. So 4, sorry about the noise, it's lunchtime. 4 divided by -2 is -2. So just be real careful about factoring out stuff. To verify, you can always multiply -2 times -2 to make sure you get positive 4. And we now have no leading coefficient, so we can complete the square. Blue, pink, okay. Divide by 2 makes this -1. Careful, that's a negative. And then squaring that is +1. -1 times -1 makes +1. So the -2 stays. To balance our equation, we have to notice that we're like subtracting, like this is a -2. So what we really did was take away 2 times 1. It's like -2 times 1. So we need to add 2 times 1. We just have to keep the balance. Yes. And then we have negative 21 plus 2. 2 times 1 is 2, so negative 19 on the end. And here's our vertex form. There we go. Okay, I'm going to do one of these down here, but I will let you figure out the other two from the notes. This number 2 leads to an imaginary number, which you will not have on your homework. But just be aware that that could happen. Sometimes there are imaginary answers, which really just means that the parabola does not touch the x-axis, because remember that parabolas don't have to touch the x-axis. They could be up here. So that's how you get imaginary roots. So I'm going to do this one. This one does not have a leading coefficient, so we're back to being able to just separate out our first two terms, plus 4. We have our orange number. We need to complete the square to get blue and pink. So divide by 2 makes negative 3, and squaring makes positive 9. So we just added 9. We also need to take away 9 right there to keep the balance. So the outside of this will be positive 4 minus 9 gives us negative 5. So 0 equals all of that. This is vertex form. We've made it to vertex form, but now we need to solve it. So to solve, I'm going to do this in a different color. What color? Maybe green? I don't like green. I'm not a fan. I just changed my mind because I don't like it. Okay, so add 5 so that this goes away. That leaves us with 5 equals x minus 3 squared. Now to get this squared to go away, we're going to have to square root both sides. And remember, this also gives us a positive or negative. On this side, we have x minus 3 left. So add 3, add 3. Our final answer here is positive or negative square root of 5 plus 3 equals x. We can't combine these two things because one's inside of a square root, so you can't really touch it. The other one's just a normal number. So that's really as far as we can go. That is 2 solutions to that quadratic, because there's both a positive square root of 5 and a negative square root of 5 happening there. Trying to decide if I will do number 3. I think I will. I'll do number 3 really quickly, and then we'll be done. So this one does have a leading coefficient, so we just have to be a little bit careful here. I'm going to separate out my first 2 terms, x minus 6, and then I need to factor out a 2 so that there's no leading coefficient, which leaves us with x squared and 6x. Then to complete the square, positive 6 divided by 2 gives us positive 3. Squared gives us positive 9. But we just added 9 inside parentheses where there's a 2. So we need to take away 2 times 9 on the outside. Let me highlight just for the sake of consistency. 6 minus 18, 2 times 9 is 18, so 6 minus 18 is negative 6. Sorry, negative 6 minus 18 is negative 24. Equals 0. So that's vertex form. We still have to solve it though. So I'm going to just box this so we know it's vertex form. But to solve this, I'm going to start by adding 24, because this we can get rid of. So I have 24 on that side, equals 2 times x plus 3. Now before we square root both sides, we have to divide by 2, because that 2 is outside the parentheses. So that leaves us with 12 equals x plus 3 squared. And then we can square root. It'll be positive or negative square root of 12 equals x plus 3. Take away 3 on both sides, and it gives you positive or negative square root of 12 minus 3 equals x. Oof, that's the wrong. There we go. So those are our two x-intercepts. Not pretty. The square root of 12 is not a nice number, but it's still a real number. Unlike this middle one, this one will give you an imaginary number. Okay, so that's 3-4. We have one more method to learn for finding the x-intercepts of a quadratic before we're ready for our test. So let me know if you need help. Remember that there's study sessions on Friday